What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're going to talk about the quadratic formula, the mystical, magical quadratic formula that's descended upon us by the gods, that says, here's how you find all these different pieces of your quadratic equation. Okay, maybe not really. We'll get into how the quadratic formula was derived, how they found it in another video. In this video, what we're going to talk about is how do you use it? How do you piece it together from your standard form equation? Let's get to it. All right, so the first thing that you have to have before you start with the quadratic formula is you need to have your equation written in what's called standard form. Standard form is written in terms of y equals ax squared plus bx plus c. And that is, all that means is a is the number in front of your x squared. B is the number that is in front of your value of x. And c is the constant that's hanging out at the end. Now, you're probably used to seeing this quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. But what I like to use is a different version of this. I like this one. It's basically the same thing, but instead of having one giant fraction, I've got two individual fractions. And the reason I do this is because it helps me pull out more information about the function, about the graph of the function that I might not always see in terms of this general equation right here, or in terms of the quadratic formula that you're used to seeing. So first thing is, we've got our a values. Let's find all of our a's. So we would find an a right there and an a right there, or these a's and that a right there. Then we've got our b values. In our b values, we've got an opposite of b, a b squared, and another opposite of b and a b squared. And then finally, we've got our c at the very end of all of this. So let's drop in the values that we have here and see how these things correspond to this over here. I like to list out my values. And since we're using colors here, we'll say a equals 1. We'll say b equals -3. And we'll say that c equals -8. So I'm carrying in these negative signs into here. And now I'm just going to take these values and drop them straight in here. X equals negative b. So we're going to have a negative b, which means a -3, plus or minus the square root of -3 squared, b squared, -3 squared, minus 4 times a, 1 times c, -8. All of that is over 2 times a, which is 1 again. So if I were to continue working down this left side, and then we'll go over here to the other version. We've got a +3 plus or minus the square root of -3 squared is 9, -4 times 1 is -4 times a -8. So -4 times -8 is a +32 all over 2. Then we have x equals 3 plus or minus the square root of 9 plus 32, which is 41, divided by 2. That doesn't do a whole lot for us now, so we kind of have to convert this into a decimal, and you could probably figure out from the graph sitting right next to us what these results are going to be, but let's drop it into our calculator all the same. So I'm going to do my alpha y equals so I can get my fraction option, and I am going to put these values in. Now I have to do it 2 times because I've got that plus or minus in there. So I'll do one version with a plus and one version with a minus. So I've got 3 plus the square root of 41, all of that over 2, and I get a value of 4.70156, da 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 da. Or I can have to put a minus in there. And look at this. If I go up, if I arrow up 2 times and I get to that same value, that 3 plus, if I hit enter, now I can just arrow over and find the spot that I want to go to, and I can just delete that and put in a minus. So I don't have to type in all of that. So minus negative 1.702. Hey, look at that. Here's negative 1.702 and 4.702. Look at that. My plus version is 4.702. Cool. So I found the two x-intercepts. Great. That's exactly what I wanted to do, right? I wanted to find the solutions of this thing. I wanted to find where it crossed the x-axis. I did that. Why are you trying to show me this other formula, Caster? Well, let's take a look at it. I know, but why do I do this? The reason I do this is because of this piece right here. This thing is our axis of symmetry. Our axis of symmetry is where the graph will fold over on itself and it will be exactly the same thing. By splitting this in half, I've just found that axis of symmetry right here. And I see that at 1/2, 3/2, 1/2. So by doing this, I'm still going to end up with the exact same things for my two x-intercepts, but in the process, I've already broken out a piece that says, here, 3/2 is part of my function as well. And as you get more fluent with this, as you get more practice with this, you might say, well, look, here's my 3/2 right here as well. So I've got my axis of symmetry there also. Yeah, you can do that, but a lot of times we don't realize what's actually happening there. So what does this mean then? What is this plus or minus square root of 41/2? This distance right here is plus square root of 41 divided by 2, and this distance right here is minus square root of 41 divided by 2. So that distance from the axis of symmetry to one of your solutions and to the other solution is just this other piece that we're adding or subtracting on there. And that's, again, something that I don't think that people don't always realize. So I think it's a nice thing to have an understanding that that's where this comes from. And where do I get this negative 10.25 from? Well, I just take this 1.5 or this 3/2 and I drop it back into my original equation, and then I'll get this piece down here. That's the quadratic formula. You have it in, you get your equation in standard form, you get it written out where everything is expanded out, and then you just drop it into your formula and you find either the axis of symmetry and your solutions, or you find your solutions. I hope that was helpful. I hope you learned something a little bit new in there. If you did, give me a thumbs up, give me a like on the video, and I will see you in our next one.